already here. Anthony's already here. Liz, get there. Chase, back one. Get back. Thanks. This video is a series of pictures. That means that we have to pay a lot. We have to pay a lot of attention to what's happening in every single picture. Because of that, Derek, go and turn off just the front light. I'll be watching for pencils to be moving. I will take silent points.
And we're going to talk for a couple of minutes on how you can see a magnetic field. So what I'm going to do is take a typical bar magnet, and if I put the bar magnet down and put some compasses, and these are not fancy, these are just regular directional compasses, around the magnet, all of the arrows will be pointing toward the north pole of the magnet. Now, typically people think that the red tipped part of the arrow would point toward the north end of the magnet, but these compasses are south-seeking. So when you look at this, you can see that the red arrows are actually pointing away, and the blue is pointing toward the north end of the magnet. If you doubt this, I can take the magnet, because we've got the north end with the little notch in it, that's how I know it's north, and I can turn it around, and the needles will reverse, so that now the red tips are pointing, clearly you can see away from the north end. So this is one way to see a magnetic field, because magnets exert this force that we cannot see. And there's another way we can look at it as well, by taking a sheet of plastic, or in this case it's a little plastic frame, put it on top of the bar magnet, and I'm going to use some zinc-coated chips. And I can just very carefully pour these on the plastic.
Can you turn off Skylar's trying to be in 3, in 2, Derek Isaac here. 1. So what they meant by zinc chips is essentially just very, very small pieces of zinc metal. So instead of it being a metal bar, it's just small, small flakes of zinc. This is indeed question 3.
And I not only can now see the field that's created by this bar magnet, which is really typical, the kind you see in your typical textbook. The closer the lines are, the stronger the magnetic field is. So if this plastic piece was even bigger, the filings would just get thinner and thinner and thinner. If you wanted to test how far the magnetic field extends, all you need to do is keep moving your compasses further and further out, and when they're no longer affected by this magnet, but are affected just by the Earth's magnetic field, then you'll know that that's the limit of this magnet's field.
So congratulations to those scholars who were keeping up with the notes. They all received a bonus point just now. Derek, I need you to go and hit my lights. Derek, next time, please let Derek turn on the lights when that was his direction. Thank you. Scholars, the correct answers are up on the board. We saw magnetic field demonstrated in 2 different ways. It's important that we see it demonstrated because you can't actually see a magnetic field. Instead, what what you end up seeing is you see objects and materials which are affected by that magnetic field. So that's why we looked at the zinc shavings and we looked at the compasses. Coria. Put it at the top of your desk, leave it alone. Thank you. Aishan, question?
Yeah, first, what is zinc and where do you get zinc? And where does
Excellent.
it come from?
Yep, so zinc is one of our metals that we have on the periodic table of elements. That means that we can find zinc as either an atom all by itself, or a group of the exact same atom, or we can find it in different compounds, like zinc and oxygen together would make zinc oxide, which is a completely new material. So we can find it in a lot of different natural places. Adriana, thank you for finding that. Just get it back to focusing up here. Thanks. Really appreciate it. So, we've talked about different physical and chemical properties of objects, and now we're talking about how forces affect those properties in objects. From yesterday, we remember that, chase it up. Sit up, please. Thank you. From yesterday, we remember that a magnetic field is a force field around a magnet. We also remember that here. Thanks. TV. We also know that a magnetic field is a field where the object doesn't actually have to touch the magnet for the force to affect what is out there. We saw that yesterday with our compass. We also saw that there are two things Derek, just one grab a seat, sit down.
What you mean when you say distance from?
Derek, just one grab a seat, sit down, raise your hand correctly. Go. I'm hearing a lot of murmuring. I need the murmuring to be at a level 0 tonight. Aishan, what is your question?
How do you know which side is north and which side is south? They ain't got no colors on it.
Excellent. So how would we? So how would we know if something was north and something else was south if it doesn't have N or S written on it? Can any scholar remember what happened in our video yesterday when we cut a magnet in half? I have 2 hands. I need more than that. Chastity.